Okay guys, so this is a video explaining how a cell works, how an electrochemical cell works. So before you can get a cell, you need a half cell. A half cell is when you have an element in two different oxidation states. So I've got an example here, and I have a solid strip of magnesium represented in the equation here. I also have some magnesium ions. Now, ions aren't going to be solid, they're going to be aqueous, so they're going to be in the solution. So that's my element in two different oxidation states. Ions go in the solution. The solid, if there is one, will be the electrode. If you don't have a solid in your equation, we would just use platinum as the electrode, as it is inert. You'll notice I've also put a number here next to it. This is the electrode potential. Now, as a bit of a simplification, we can say the electrode potential is the amount of electron density on the electrode. So how many electrons are on the electrode, as a bit of a simplification. And the charge of an electron is negative. So the more negative your electrode potential value, the more electron density is on the electrode. Okay, so let's just zoom into this electrode using my amazing picture here. What's going to be happening is we're going to have, if we just have a half cell on its own, a dynamic equilibrium. So my magnesium atoms can lose, these are my magnesium atoms here, can lose 2 electrons. And the electrons, as metal is a conductor, will conduct up through the electrode and possibly go into the wire. That will release this atom, so it's no longer an atom, it has been released as an ion. And then the 2 electrons have been released. Conversely, this ion could hit the electrode, pick up the 2 electrons to become the atom. So we have an equilibrium going on, and if you just have a half cell on its own and you leave it for long enough, you'll reach a dynamic equilibrium, where your forwards rate equals your backwards rate, and these are just interconverting. Interesting things happen though if you connect the half cell to another half cell. So here I now have 2 different half cells, and you'll notice their electrode potential value is different. So the fact that this has the more negative electrode potential value, as a bit of a simplification, we can say it means it has a lot of electron density on the electrode. Over here, we have a less negative electrode potential, so there's less electron density. It's worth pointing out, even if the electrode potential value was positive, there'd still be a little bit of electron density. The fact it's positive is just because it's a comparison to something called the hydrogen half cell. So there'll always be a little bit of electron density, but the more negative the electrode potential, the more electron density there is. And so what's going to happen, and this is where this sentence at the bottom comes in, if you remember anything from this video, remember this, the rule is the more negative half equation gets oxidized. So when it was on its own, we had both oxidation and reduction happening. When we connect it to a second half cell to make a cell, the more negative of the 2 will be oxidized. And so if we look between these 2, we can see that this is the more negative. So although we always show reduction going forwards when we set up the half equation, in reality, you're going to be getting the backwards reaction. It's going to be getting oxidized. Oxidation is loss, which means this half equation here is going to be getting reduced. Reduction is gain. So you'll know which way round these half equations go just by remembering this key rule: the more negative half equation gets oxidized. But let's have a look at why that is. So the fact that I have more electron density here means the electrons are going to be repelled They're going to go across the wire, power whatever it is, if you've got an appliance, into the other side, just because of electron repulsion. So look, this side is losing electrons because it has a higher electron density, and we know that because it has a more negative electrode potential. Then this side is gaining electrons. All we need on top of that is to complete the circuit, because at the moment we don't have a complete circuit, and we do that by adding a salt bridge. This can just be anything as simple as a bit of tissue paper soaked in potassium nitrate. And that completes the circuit. It also has one other function, which I'm not going to get into now, but your teacher will go through in lesson. So that's how a cell works. You're literally setting up two different areas of differing electron density. So the electrons are literally pushed from one side to the other. And you'll know which side has more electron density and is therefore losing the electrons by looking at the electrode potential. Bosh.